Good morning and welcome to this discussion. We want to see how we can be able to tackle some question from the KNEC past papers. Now for today, we can see that we have a question here that a continuous random variable t has a probability density function defined by f of t equals to c squared all over 2 exponent minus ct, and the range is that t is greater or equal to 0, f of t equals to 0. Otherwise, I think the function is on the whiteboard. So using this given information, they want us to determine the value of c. Then Roman 2, they want us to determine the mean, and then Roman 2 for us to be able to determine the standard deviation. Okay, so let us see how best we can be able to solve this problem. This is the function that f of t equals to c squared exponent minus ct all over 2. Then they are saying that t is greater or equal to 0. F of t equals to 0 otherwise. Now we start with Roman 1. They want us to get the value of c. Now there is a property that we need to apply of a probability density function. We know that if a continuous variable, for a function to be a probability density function, one of the properties is that the integral of the function must give us 1. Therefore, what we are saying is when we integrate c squared exponent minus ct over 2 dt, it must give us 1. Now we're integrating from, they are saying that t is greater or equal to 0, meaning we're integrating from 0 to positive infinity. Now here c squared and 2 are constant, so we can take them outside the integrand sign. So I can write this one as c squared over 2 integrating from 0 to positive infinity exponent minus ct, then dt must be equal to 1. Now when you integrate exponent negative ct, we shall be able to get minus exponent minus ct all over c, integrating from 0 to positive infinity must give us 1. Now I can take out 1 all over c, so that I have c squared all over 2c must give us 1. Now I can now substitute in with the limits, because this will cancel the one factor of c there, so we remain with c over 2 into minus exponent minus e times now the positive infinity, then minus exponent minus c dot 0. We substitute with the lower limits, must give us 1. Whenever you substitute with the positive infinity, you'll be able to get 0. Negative and negative is 1. Exponent, this is now 0. Exponent 0 is 1. So here we have c all over 2 times 1 equals to 1. So we are saying c over 2 equals to 1. Therefore, c equals to 2 times 1, which is equals to 2. So we are saying that the value of the constant is what? Is 2. value of the constant is 2. Now, mean, how do we get the mean of a probability density function? Remember the variable is t, so expected value is given by, we are integrating from 0 to positive infinity, so it will be t dot f of t, then dt. So this will be equal to t. Now what is our f of t? Our f of t now equals to, now this is 4, because c is 2, so it will be 4 by 2 exponent minus 2t, so which equals to 2 exponent minus 2t. So that is our f of t. So this will be times 2 exponent minus 2t, then dt. Now from here, we can take 2 outside because it's a constant, 2 the integral, then t exponent minus 2t dt. Now here we shall integrate by parts. This is u, that is dv. Now, why do we say that t is our u and dv is our exponent minus 2t? There are 2 points that you need to know when you want to integrate by parts. Number 1, we normally say that when the power of t is present, is taken as u. When the power of t is not present, then the log term is taken as u. When the power of x is not present, the log term is not present, then the exponential function is taken as u. But in our case here, you can see the variable t, which is our t is present, so it's taken as u. Automatically what remains will now be the dv. Now integration by formula, by parts formula, is given by uv minus integral v du. So in this formula we need to calculate du and get the value of v. Once we get them, we insert in this formula. Now here we are saying that u equals to t. Therefore we differentiate with respect to t here. So we have du dt equals to, when you differentiate t, you get 1. Therefore du equals to dt. Then again we are saying that dv equals to exponent minus 2t. dv equals to exponent minus 2t. Now to get the value of v, we integrate this equation on both sides. Integral of dv equals to the integral of exponent minus 2t dt. When you integrate dv, you get v. When you integrate exponent minus 2t, you get minus exponent minus 2t all over 2. So now we have v, we have du. We can now come and substitute in this formula. Remember, we have 2 outsides. So our u is now t, our v is minus, so we shall have minus exponent minus 2t all over 2 minus this sign. But before that, remember the limits from 0, then minus from 0 to positive infinity. Our v is minus exponent minus 2t all over 2. Then our du equals to dt like that. So this is the same as 2 into, I can write this one as minus a half t exponent minus 2t, and then minus and the minus will be positive, and then you take out 1 all over 2. Like that. And then we integrate exponent minus 2t. So to be equal to 2 into negative a half t exponent minus 2t plus a half. When you integrate exponent minus 2t, we get minus exponent minus 2t all over 2. Remember the limits, like that. So this will be equal to 2 into minus a half t exponent minus 2t. Then here we can take out a half, so that we have plus 1 all over 2 dot 1 all over 2 into minus exponent minus 2t, like that. We have this, the limits, then plus now is 1 all over 4 into minus exponent minus 2t. So at that point, then we now insert in the limits. Now here we have where there is t exponent infinity times exponent minus 2 dot positive infinity minus minus a half dot 0 exponent 0 plus 1 over 4 into minus exponent minus 2 dot positive infinity minus minus exponent 0, like that. So here the whole of this will be 0, the whole of this bracket here will be 0. Therefore we have 2 into, this is 0, minus and minus is positive, exponent 0 is 1, so we have 2 into 1 over 4 times 1, which equals to 2 over 4, which equals to 1 all over 2. So 1 all over 2 is our mean. 1 all over 2 is our mean. Now we need to get standard deviation. We know that standard deviation equals the square root of variance. Now we need to get the variance of this probability density function. Now variance is given by expected value of t squared minus expected value of mean squared. So we already have mean, so what we need is for us to compute the expected value of t squared. Then we shall subtract the mean squared. We'll have gotten the variance. Now the expected value of t squared is given by the integral of, now we are integrating from 0 to positive infinity, so it will be t squared dot f of t dt. F of t dt. Now, this equals to, from 0 to positive infinity, t squared. Our f of t is 2 exponent minus 2t dt. Now, integration by parts again. T squared is our u, but before that, we can take 2 outside this because it's a constant. Then we have t squared exponent minus 2 dt. Now we shall integrate this one by parts. So u equals to t squared. Differentiate with respect to t, we get 2t, meaning du equals to 2t dt, and then dv equals to exponent minus 2t. To get v, we integrate both sides. When you integrate dv, you get v. When you integrate exponent minus 2t, you get minus exponent minus 2t all over 2. Integration by part formula, uv minus integral v du equals to, we already have 2 here, so we write 2 into, now we substitute in this formula. Our u here is t squared, our v is negative, that, so we shall have here minus t squared exponent minus 2t all over 2, remember the limits, minus, remember the limits, our v is minus exponent minus 2t all over 2 dot, our du is 2t dt, 2t dt, like that. So these 2 and that 2 will cancel, so this equals to 2 into, we have minus t squared exponent minus 2t all over 2, then negative and negative will positive, plus, now it's t exponent minus 2t dt. Now from here we integrate by parts again. You can see this is our u, this is our dv. So we have here u equals to t du dt equals to 1, du equals to dt, then dv equals to exponent minus 2t. Integrate both sides for us to get the value of, v. When you integrate dv, you get v equals to, when you integrate exponent minus 2t, you get minus exponent minus 2t over 2. Therefore, we can now rewrite this equation equals to 2 into minus a half t squared exponent minus 2t then plus. Now remember this, we are integrating this by parts. Our u, remember it's uv minus circle v du. Now our u is t, our v is now minus exponent minus 2t all over 2 minus from 0 to positive that, our v is minus exponent minus 2t all over 2, our du is dv equals to dt. Now rub this, now rub that. So this equals to 2 into minus a half t squared exponent minus 2t, then here to be minus a half t exponent minus 2t, then minus and minus it will be positive, and then we take out 1 all over 2 because it's a constant, plus 1 all over 2. Then we have the integral of what? We have that integral. Then we now need to finish up integration by integrating the last part of this expression. Let me wrap up here again. So here we have 2 into minus a half t squared exponent minus 2t, then minus a half t exponent minus 2t, and then plus a half. When you integrate the exponent minus 2t, we get minus exponent minus 2t over 2. So we are through with the integrating that. So we can take out 1 all over 2 there, so that this equals to 2 into negative a half exponent negative a half t squared exponent minus 2t. Then you have minus 1 all over 2t exponent minus 2t. Then you take out 1 all over 2, so that we have here plus 1 all over 4 into minus exponent minus 2t. So at that point then, we now substitute in the limits. Now from here you can see that this bracket, when we substitute in the positive infinity, then minus, we substitute in the lower limit which is 0, or this bracket will be 0. Likewise to here, when we substitute the upper limit which is positive infinity, then minus, we substitute in the lower limit which is t, which is now 0. This one again becomes 0. And then we are now remaining with this. So we have this equals to 2 into 1 all over 4 into, now here we have minus exponent minus 2 now times positive infinity. Then we have minus exponent minus 2 times, now we substitute the lower limit which is 0, like that. So this equals to 2 into 1 all over 4. Now this will be 0. Everywhere you substitute with positive infinity to always give you 0. Now minus and minus will be positive. Exponent 0 is 1. So we have 4 times 1. So this equals to 2 all over 4, which is equals to 1 all over 2. So we are saying that now this is what? This is expected value t squared equals to 1 all over 2. But remember what we said? me wrap here. We say that variance equals to expected value t squared minus expected mean squared. Therefore, variance equals to, this is now a half minus mean was a half, so it will be a half squared. So this equals to a half minus 1 all over 4, which equals to, the LCM is 4, 2 times that, this goes there, so we have, this goes that 2, we have 2 minus 1, so this equals to 1 all over 4, which equals to 1 all over 4. So variance equals to 1 all over 4. Therefore, standard deviation will be equal to the square root of 1 all over 4, which equals to 1 all over 2. 1 all over 2. 1 is t a half. Yeah, that is it. So thank you for watching and listening.